Hello everyone, welcome back. So in this video what we are going to see is, this is a normal stepper motor actually, and one of the main problem with this stepper motor is that we don't have a feedback for this motor actually. So you just give a pulse to the coils of the motor, that is a plus, a minus, b plus, b minus actually, and then the motor rotates actually. So these stepper motors comes at various step angles, so there is 1.8 degree per step, and there is also zero point 0.9 degree stepper motors. Now what we are trying to do is we are trying to make this stepper motor smart. So what we are doing is we will be using this board actually. So this is an CAN adapter encoder board for this stepper motors. So what we can do is we can attach that to the back of this motors like this, and what we do is we keep a magnet here, so it can be a grade of N35, and we have a magnetic encoder that is attached to the back of it. So in this board we have not attached, but we are using a sensor called MT6701, and once we attach the board behind the motor, so we can remove the couple of screws in the back of this and then attach it actually. Now what we can do is we can make the motor smart, as well as also we can achieve a configuration called DC chain. So here in simple terms, like we have the power that is coming from here, so we have a 24-volt line that is coming here actually, and we have also connected this second motor also to the 24-volt actually, and the only wire that goes from the motor 1 and motor 2 is only this cable actually. So this is an CAN communication cable. So we have three wires going in, one is CAN high, CAN low, and ground, and I have connected the USB-C also for programming. So it uses an ESP32C3 chip actually, so we can program each of this control board. Now let us see what we can do with this. So what I am trying to achieve here is I am trying to move the motor 1 by 90 degree, and then let's see if we can use this to follow it. So the idea is like this has an encoder within it, so it should perfectly move 90 degree, and also once the shaft moves we'll send the encoder data of this motor actually to the second motor. So the shaft of this motor also can move actually. Now this can be used in wide range of applications actually, this particular configuration. uh, so let's see, like we have built a dashboard actually to demonstrate this. So we have a node 1 here actually, right now it's at 340 degrees actually, and node 2 is around like 340 degrees also. Now let's see, like we'll try doing a rotate operation actually. So I'm clicking rotate and it will rotate 90 degree, and we can see like okay, it has reached 70 degree actually, and the node 1 also tried to follow the same. Now let's see this in action actually. So I'm clicking rotate, and then so you can see the both of the shafts are rotating like in a synchronous fashion actually. So this is earlier difficult to achieve in the normal board. So this is a board that we have developed actually, and it costs around like 3,500 rupees actually, but you can make the entire steppers closed loop actually. So if you want to know more about this, then you can check in the link in the description, and you can make a purchase actually. So we have only limited quantities of this actually. So you can create robotic arm with this, and a lot of leader follower stuff actually, and the DC chaining is one of the uh, interesting feature with this board. And also another thing is we can connect the limit switches with this board actually. So you can connect the limit switch, for example you can connect the normal limit switch as well as the proximity based limit switch also. So you can build a 3D printer with this actually. So there is a CAN input actually, and then there is a CAN out also. So you can use this board to chain multiple motors actually. So there is an termination resistor in this board, so here is a termination resistor. Once you can remove that, like you can connect more than 3 motors or 10 plus motors all together in a single 4 wires actually. This will help you reduce a lot of mess actually. So that's it about, like, we'll share you more updates about this. Thank you.